Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field. I am happy to have Automotive Seminars as a sponsor for the show. Now, if you're not familiar, Automotive Seminars is a diagnostic technician training company. They've got a website that there'll be a link to in the show notes. And what they offer is top-notch training to technicians like us in the field. I've been taking their training courses for years and have got a ton of benefit out of it. They got top-notch instructors, John Thornton, Scott Shotton, Scott Manna, and every other month they've got a 2-night course that you can sign up for. Join in, ask questions, and afterwards, you've paid for the course, you can access a recorded version whenever you want. You can rewatch the class 2 years later in case you wanted some details on it. And that is a fantastic feature. So make sure to check out the website to see what courses they have available and what's coming up in the future. Hey, what's going on, automotive world? Welcome to another episode of the Automotive Diagnostic Podcast. My name is Sean Tipping. I'll be your host once again for this week's episode. Thank you so much for joining me. It is just me on the show this week, once again, coming at you with another case study. Actually, we're going to wrap up the GMC Yukon that I was talking about last week. So if you didn't listen to that episode, go back 1 week. I talk about Global B VIP architecture in the newer GM vehicles and the things that you might want to be aware of there. Now, when I ended the episode, we still had to go back to that vehicle one more time to program a brand new instrument cluster. So again, if you want more details on that specific vehicle, you can check out the episode. But we went back there on Monday because they got an instrument cluster and we were not able to program it. Or I shouldn't say we weren't able to program it. We programmed it, but then once we got to the S-Stack, the security handshake, it aired out again for the instrument cluster. And that was the issue that we had ended up with after attempting to program another control module, the serial gateway module. But we ran into the same thing, aired out on the cluster, P16 as the ECU at the air for the S-Stack, and we're right back in the same boat. So we actually called GM Tech Support on this because we're following things, to the letter as the service bulletin and service information suggests on these GM Global Bs and what you're supposed to do if you get this error, right? And we had removed the cluster from the network and bypassed the network wires, and it passed without the cluster. This was the original one. And according to GM documentation, if it passes without said module, well, you replace that module after checking it for updates. That's what we did. And this is a brand new instrument cluster from GM. So I was a little stuck and we called GM Tech Support, which they attempted to help us, but didn't really get us anywhere. One suggestion they made was to use Ethernet connection to the MDI2 rather than a USB cable. And I think I mentioned in the episode last week that I've talked to people that with the front camera, you might need to be using Ethernet connection, but I haven't actually run into it. We tried it. It didn't change anything, still failed. And again, you could remove the cluster from everything and then it would pass no problem. So kind of stuck here, and I had actually sent my other one of my techs out to do that part. We ran out of time and ideas, so I was like, well, I'm going to research it a little bit more. We'll come back and we'll keep trying because we want to get it figured out for this customer. Obviously, I must have missed something or not understanding something. Not sure what, but got to research. So in the meantime, and actually, this was earlier on Monday, a gentleman had reached out to me. His name is Josh Hutchins, and he is a GM world-class technician. And he was just commenting on the podcast episode that I did and gave me some, other tips and advice on it, which is greatly appreciated because obviously I don't, work in the dealership. I don't know that stuff firsthand like someone in a dealer is going to be dealing with it every single day and probably has training on it from people who are, at the engineering level. So anyways, I reached out back to him at this point and said, hey, do you have any tips for me? Because here's my situation, right? We went through everything, on this vehicle. We followed the procedure and we're still ending up with the same error. And he actually was able to come back to me with some information on how to proceed and fix this vehicle, which was huge because I don't know that I would have been able to figure this out myself. So there was an internal document within GM's internal system, and I don't know what it takes for something to go from something like this to a TSB, but I've seen stuff similar like that with like star cases in Chrysler vehicles where it's not a service bulletin and you might not be able to find it in aftermarket service information, but it's there and it's, within the dealership, or at least if you're paying for a OE subscription. I don't even know that I would have been able to find this General Motors document because it looked like it was through some sort of internal technician forum or something like that. Anyways, a technician had been experiencing almost the exact same scenario as me. Now, they hadn't replaced the serial gateway module, but they had a new telematics and a new cluster in this thing, and it was still failing for the cluster. And what they ended up doing was disconnecting one of the connectors on the serial gateway module and then running the SDAC and then plugging it back in and then going in and finishing the setup of the cluster. And it was all good to go. Everybody was happy. And you didn't have to disconnect the cluster to get it to pass this time. And the connector that is on the gateway module, it has some Ethernet connections on it, but not the ones that actually go to the cluster. So the cluster's on for the handshake, and I'm not exactly sure what's happening. It looked like it was suggested by engineering that the gateway is reaching out to or onto networks to get information about a security handshake that it shouldn't be. I'm not entirely sure. I didn't really pursue it any more than that because it worked. Now, the note in the document, and this makes sense, if you would attempt to replace another module and do an SDAC, you're probably going to run into the same issue. So will this eventually turn into an actual service bulletin, known information out there? Very possibly. I don't know how common it is. I don't know how lucky I am that I was the one that ran into this exact problem, but since I just put out the episode on Global B and I was saying, hey, you might run into it where you have to replace a module, and that could be true, right? That could still happen. There are going to be some hurdles and challenges as we get into these things because, like I did with this one, I replaced the module that I'm supposed to replace based on what's going on, and still had the issue, and I had to do something with the series of unplugging and plugging back in while running the SDAC. Yeah, don't know that I would have figured that out on my own, or it would have taken me a very long time to do so. So anyways, just filling everybody in on that. So, the whole story. I'm not, I want to be transparent about the stuff I talk about on the show. So anyways, big thank you to Josh, because again, that would have taken me a very long time on my own. It's all about who you know in this industry, for sure. All right, now into the case study for today's episode, and a little bit of information on the system is on a 2021 Tesla Model Y. And it seems to be lately we're getting all kinds of really fun cars to deal with, and this one was no exception. This one, the actual problem that we found, nothing crazy. It wasn't anything like, oh wow, that's a crazy fix. But I have not dealt with a whole lot of Tesla diagnostics. Now, I've gotten my hands into a few of them, done some stuff here and there, but it hasn't been anything real involved, right? Like, oh, there's a parking sensor that's not working. It's power, ground, and LIN. There's a frunk actuator that's not operating. It's power and ground, and you can get through that stuff. And I've learned a little bit about the wiring diagrams with Tesla, the service information, and the tooling. Right, you can connect to the car to get information in a few different ways on these Teslas. The Autel has a series of connectors, and one of them, specifically with this Model Y, you take a connector.
Hey, have you ever been faced with the challenge of sourcing, installing, and programming a used control module in a vehicle? I know a lot of us have. It seems to be happening more and more often today with the volume of control modules on vehicles, the cost of some new ones, or even the availability of new control modules. In some cases, used may be the only option. So what do you do here? I strongly recommend checking out SJ Auto Solutions and Tommy Oliva. Tommy offers a cloning service for used control modules to make these things plug and play for the vehicle that you're working on. In a lot of cases, he is also able to source the control modules if you're unable to locate one for the vehicle that you're working on. But once you get connected with Tommy, he's going to offer fantastic support from start to finish to make sure that that control module is going to work in your application. He's also got tech support that he offers through his website, along with some free resources there as well on information about used control module programming. So make sure to check out SJ Auto Solutions. I can't recommend that enough.
A part on the back of the center console, and you put this jumper harness in between. The jumper harness has no BD2 port. You plug your Autel into that, and then you can communicate with modules on the car. And that I've done that a couple times. You can also just get Tesla Toolbox, and it's expensive. I think it's like $100 a day or something like that. I've only actually made the purchase a couple times where we needed it. Everything else I've been able to do without it, but that is an option, and it's going to connect to the car in a different spot than what you're doing with your Autel. But there's some cables that you can buy a set of on eBay for relatively cheap. The other option you have, and I found this to actually be really helpful. I'm sure there's limitations to it, but putting the car into service mode and just using the infotainment pad on the center of the dash to get the information that you need. And you can get the trouble codes, and you can actually get into some of the systems and figure out what's going on with the car. And that was my experience with this one. So let me back up and tell you what's going on with this car. This is at a body shop, and I guess this thing has been sitting for at least 6 months after an accident, and there was some body work done to a quarter panel. There was a subframe that was replaced that the shop did not tell me about. At first, I had to find that part on my own, but there was a subframe that was replaced along with the quarter panel. And they said when the vehicle came to them, this is the story I got up front, when the vehicle came to them, it was charging fine. It was just smashed up from the accident. They performed the work to the vehicle, and then after the fact, it would not charge anymore, right? So you plug the charger in. I think it blinks blue at first, and then it goes to red. It basically airs out, and you can see on the information pad inside that it's not charging, and this thing's at 0%. It's been sitting for 6 months. And anyways, they tried replacing the actual charger connection, which is a unit on the left rear quarter panel there. That didn't change anything for them. They had gotten an actual Tesla charger because this thing's sitting in a shop, and they thought maybe it was their charger that they had, and same thing, still not charging. So anyways, they call us to come in and take a look at it and see what's going on. And basically what I end up finding, well, first let me actually tell you about putting the car into service mode. So there's videos out there where you can actually, if you just go to service.tesla.com, there's a ton of information on this, but you can watch videos on how to use it. There's a PDF that's just the entire operation of service mode on Tesla. And one of the things I like doing, this is a little bit separate, is if I have a big long PDF, sure, I can read through it, definitely, but I'll throw it into a large language model. And then as I'm working, I can just ask that language model questions about the PDF as I'm trying to figure stuff out. And that's kind of what I was doing here to guide me through like finding what I would want to find within service mode, or how I would operate service mode to get to where I want to go. And in order to do it, it's pretty straightforward. You just pull up the menu and then you go to software. You'll see the actual like name of the vehicle written out in text. You hold that with your finger for a few seconds, let go, type in service. There's going to be a window that pops up where you with a keyboard. You type in service, you hit enter, you agree, and then it goes into service mode. And you can tell it's in service mode because there's a big red banner all the way around the infotainment pad. So you can tell, like, obviously, okay, this is in service mode. And then you have a menu of a whole bunch of stuff that you can do. And I've not explored all of it, but again, there's a instructional on all the details and all the things you can go through. But one of the areas that you can look at on these Tesla vehicles is both the HV battery, the charging system, and something called the HVIL. And this is where I ended up getting to with this vehicle. And I should say I hooked up the Autel and I scanned it for codes. I actually didn't get anything really useful out of the Autel when I was connected to it. Like, I didn't see anything obvious of why this thing's not charging or any errors. There was a couple codes in there, and also the 12 volt had been dead for some time as well. So we jumped that and put a charger on it, but I didn't really get anything useful from the scan tool side, which is why I went to the service mode side. And it was basically, my plan was to see what I could get through service mode. And then if I needed to make the purchase for, the actual Tesla toolbox, I'll do that. But like I say, I found a number of things you can actually figure out just using either the aftermarket scan tool or using the service mode. Right. That doesn't cost you anything. You don't even need a tool. You just need to enter service mode. So again, one of the things I can look at is the high voltage system on this, which is kind of the direction I'm going because it's not charging, right? So why would it not be charging? Is it something with the charger? Is the high voltage system disabled for some reason? Let me see what I can find out here. And it is pretty obvious once you're into the high voltage section of service mode that it is disabled and the contactors are open. Now it does show the battery's at 0%, but it is not closing the contactors, which is not going to allow you to charge the battery, even if the charger is plugged in, which at that point, I'm like, okay, well, I understand why it's not charging. Now I have to understand, okay, why is it not allowing the contactors to close? Is there an error somewhere that it's seeing within the high voltage system that's just saying, hey, I'm not going to do anything until you fix this? Like I said, they had actually replaced the charge port itself. And I did do a visual on that just to make sure, okay, is everything plugged in? And the connector was a little bit wonky on there. You could tell they've been messing around, but I didn't see anything that was definitely out of place there. And looking through the menus within the service mode and within the high voltage section, there was an option to view the HVIL, which is high voltage interlock loop on the vehicle. And this is something that I hadn't dealt with before in a Tesla and wasn't really familiar with, but kind of the reason I wanted to talk about it, because I thought it was actually pretty interesting. And once you understand it and what it is, it's actually pretty straightforward and pretty informative onto what's going on and how you would find a fault. But what this HVIL circuit is it is a loop of a 12 volt wire and connections and some resistors, but it's a 12 volt circuit. Okay, so this is not a high voltage circuit, but it is meant to monitor the high voltage connections at the high voltage components. Okay, so it leaves the high voltage battery, which is a battery control unit. It leaves on a 12 volt connection. right? So this is just a regular connector with a lock lever. This is not one of the big orange ones, just regular connector. And it leaves on a 12 volt small gauge wire, and it runs a loop all the way around the vehicle through some of the high voltage components. Now, on this particular Tesla, there were other interlock loops that just went to one component and not through others. But this main HVIL loop goes from the battery on this Tesla to the rear drive unit, and then up to the front drive unit, and then back to the battery. And it completes a loop. Now, there are 3 resistors within the components. There's going to be one in the high voltage battery, there's going to be one in the rear drive unit, and there's going to be one in the front drive unit. They're all 60 ohms. So kind of reminded me of CAN, but I mean, there were 120 in CAN, 60 total. But anyways, there's 60 ohms in each one of these components. So what it does, and this is the part that I didn't really get until I actually read up on it, but there is a technical service bulletin in which you can Google from Tesla on training on the HVIL circuit. And it's just, it's free. You can find it, read up on it, and everything made a little bit more sense there. Because I did kind of chase my tail a little bit here. Like I recognized, okay, there's something going on here. And maybe I should stop and explain how I made that determination. When you get to the screen in service mode where it shows the HVIL, it shows that it's off. Or at least for me, it showed that it was just off. Nothing's happening. And there's a button that says force HVIL on. And it allows you to turn this on if it's off. And what happens is the high voltage battery unit actually outputs a voltage onto this circuit. Now, I found out if it's open circuit, you're going to have about 8.8, 8.9 volts being output onto this circuit. Okay, but it shows you right on the screen what it expects to see on this circuit, and it is not 8.8 volts, but you can actually force it on for a period of time. It'll stay on for about 60 seconds, at least on this one. And you could see not only what the voltage was, but it shows you a physical loop of it going around the car and what components it connects to. And once I actually pulled up the HVIL training document, I'll put that in the show notes, by the way, so that you have that. Again, it's free. You can just find it on Google. But it actually shows you exactly how this circuit works. Not in precise detail, but once you understand what's going on with it, it shows you everything. And I was looking at it. That's the funny part of like educating yourself kind of on the fly. And then after the fact, so you can talk about it on a podcast, is you look at the components, you're like, oh, it was showing me exactly how this thing worked and where it went. I just didn't have a full understanding. So let me explain to you, and I'll see if I can post this picture in the Facebook group too, because the picture really kind of does it justice. And I think it's cool that it's just built into the car. Like, I'm not on a scan tool here. I'm not, in service information for this. It is on the screen on the car I'm working on, and it shows me exactly how it's laid out. So high voltage battery, we're going to output 8.8 volts. And then through the components, and it shows you on the screen which components have terminating resistors. Or I keep saying terminating resistors. They're just resistors. Okay, this is not a CAN network. So, but for whatever reason, when I see 60 ohms, I think CANs. But it shows you which ones have the 60 ohm resistors within them. Okay, and you could actually look and see what it's showing as a representation as a resistor. It's not the little zigzag line that I'd be used to on a diagram, but once I understand that, oh yeah, there is one there, it makes sense. And then it says right there 60 ohms. So, okay, it's in that component. And it shows you the direction that it leaves out of the high voltage battery and then to the rear unit. Now, the rear drive inverter unit, it shows you going in on a 12 volt connection to the rear drive unit. Okay. And it actually shows a little connector, a 12 volt inline connector as well. I'll get back to that. But on the drive unit, it shows that going into a 12 volt connector, into the module, across a resistor, and then here's the part that took me a little while to understand this. It actually goes through the high voltage connector itself. Okay, so that's the big orange one. And that high voltage connector has a metal conductive piece that goes through it. And then on the unit itself, there are two pins that are kind of on the outside of the actual connection, right? This isn't the high voltage part. This is a 12 volt part. And when that connector is fully seated, and only when it's fully seated, do those contacts come together, right? So the connector itself completes the circuit. And that's the whole point of this, right? If one of these connectors are not connected correctly, then it will open up the circuit. And how does it know the circuit's open? Well, if you understand, series electrical or a series electrical circuit, after each resistor in series, you're going to have a voltage drop. And again, what's cool here is you can look at the training material, and it breaks it down like you should see this much voltage here and this much voltage here and this much voltage here. And it's going to say you should have this much resistance to ground here. You should have this much resistance to ground here, because the circuit actually does end connected to ground in the battery on the other, or the battery unit on the other end. But it shows you on the screen what the expected voltage is at each point and what it actually is. So that's really helpful, right? You can look at this screen and tell where your break is, or where the section of the network. I can't stop saying it because I'm thinking about this like a network, but the section of the circuit where your break is. And again, I understand this better now after dealing with the car and after reading up on it and like going through the material. I was kind of doing it on the fly, and it took me longer than it should have to understand this. But now that I do, like if I get another one of these, this is relatively simple to figure out where you're going on this circuit. But again, it shows it to you pretty clearly in the picture on the infotainment screen once you understand how this works. So what I was seeing was out of the HVC, or high voltage control unit, I had 8.8 volts, but that is not what it wanted. It expected 3.6 volts at that point. Okay, so what that means to me is there's basically no terminating resistors connected to this. And I need to look between the high voltage battery and the rear drive unit, because it's the first thing in line. Okay. And this is where, I started looking, and I got to the 12 volt connector, and I had my voltage there when I forced it on, my 8.8 volts. So I know all the way from the battery to the drive unit, I have 8.8 volts. Then when I was down underneath, and we did have to lift this up, and this is when I found out the subframe had been replaced, by the way. Because I was like, hey, this looks brand new. Oh yeah, we did that. I'm like, why didn't you tell me that when I asked you everything that you did on this car? Well, we didn't think that mattered or was important or whatever, the usual stuff that we get. Anyways, I'm looking at the high voltage connector, and you could tell like it was latched down, it was in place, but it was not fully seated. You could tell the clip wasn't where it needed to be. And so we got it seated correctly, connected everything back up, and the HVIL immediately started working. The car started charging. You had a little green light on the little charge port in the back, and you could see on the screen the correct voltages, right? So it expected 3.6, and that's what it saw. And then on the other side of the front drive unit, it was expecting 1.2. That's what it saw. And so you can follow it around the car, and then it turns it green instead of red. So, hey, everything's working and it's charging. And that was it. So again, once I understood what was going on and I knew where to check, this really wasn't, real difficult to get through. Maybe a little bit daunting at first, and only because I didn't understand the system. But now that I do, I understand the system. There's training material out there. It's just a
pretty simple 12-volt circuit with some resistors, but it allows you to tell where the brake is, and that I could do it through the service mode on the car. Makes this actually really, really simple. Like, I'll take on another Tesla high volt diagnostics. Now, I'm sure there's way more to it than that, right? I got a simple one, but I mean, that part of it, really not that bad. Now, if you're going to go work on high voltage stuff, do make sure that you've taken the training and that you're careful, and, you know, because there is a potential to hurt yourself. Yes, there's a lot of safeties built into the system like this, right? If there's a break in the system, shuts everything down, won't turn on the contactors, but it doesn't mean you can't, you know, hurt yourself if you're being stupid. So do be careful there. One final note that I wanted to mention, on the service information for Tesla, for the actual wiring diagrams and component locations, you can use ALLDATA, and they do have Tesla information. And there's nothing wrong with that. That works great. You can also just go to service.tesla.com and go into the service information, and you can find wiring diagrams, part locations, R&R procedures for any model. And you don't even have to sign in. It's all free. Like, I don't pay a subscription for that. So that's all out there. And you can actually get some training material that's on there as well. Ton of information on these things. Now, the one thing I will say is that the component locations and the wiring diagrams were both wrong on this. And I looked up, in preparation for this podcast, every single different build of this vehicle, because when you go to select, or you're looking at information for a particular model, it's going to ask you what plant that it was built at, and there's several different options. And I did find the one that this one was actually built at, and I used that, but I checked all the other ones, and the component locations are just wrong for some of the connectors, the inline connectors. And then the diagram was just completely wrong on another portion as far as where the wire went to for that HVIL loop. So I don't know if that was just me being unlucky on this particular one, or if that's something that you're going to run into more often on Teslas, but I'm using the factory diagram there, and ALLDATA just has the factory diagram. ALLDATA had the same information that I found on the Tesla website. So just approach that with caution if you're getting into these things. But I guess I'm just here to say they're not that scary. It's not that difficult. And with a little bit of training, you can figure these things out. So that's where I'm going to wrap this one up today. Hey, just like with Josh and GM, if you are a Tesla technician, or you've got a lot of experience with them, hey, reach out. We are all smarter together, 100%. So thank everybody for listening. But with that out of the way, let's get out there, start fixing the world one car at a time.
Yeah.